Greetings to all. The session is regarding intermediate chemistry, will be helpful for your international entrance and competitive exams as well. And India is conducting JEE Advanced, JEE Mains examination twice a year for the entrance into IIT and NIT stream, that is the technical domain. NEET exam will be conducted all across India for medical entrance examination. Telangana and Andhra Pradesh governments are conducting MCET examination for BTech entrance, that is the admission into the technical domain. In addition, government organizations are conducting exams where general studies will be the common question paper will be available for all the aspirants. Their general studies content will be there. General science content, what we are discussing, the session will be very much helpful for your preparation. Let's go with the first one. The Nobel Prize in Chemistry 2010 was awarded jointly to Richard F. Heck, Haiichi Nagishi, and Akira Suzuki. So these three scientists together accorded with the Nobel Prize in the field of chemistry for the palladium catalyzed cross couplings in the organic synthesis. Nobel Prize in the chemistry. Let me repeat again. Richard F. Heck, Heiichi Nagishi, and Akira Suzuki. Here we already aware that in the organic chemistry we can observe Nagishi coupling reaction and Suzuki coupling reaction there, right? So these are the scientists who are recorded. Heck coupling reaction is also there. Palladium catalyzed reactions, we can see a cycle form will be there, so that compound will not be wasted. Rather, it will follow the cyclic cycle type of mechanism will be followed. Heck coupling, Nagishi coupling, Suzuki coupling, these are the most important named reactions we will clearly observe in the organic chemistry, where palladium catalyzed. All these three scientists individually gone with their own way of mechanism, but these three collectively accorded with the Nobel Prize in the field of organic synthesis for their outstanding contribution in the chemistry, which is the world recognition, right? Richard F. Heck, Heiichi Nagishi, and Akira Suzuki. These three scientists contributed 1/3 each for the Nobel Prize in the field of chemistry. Let me give their address regarding what their contribution, from where they are contributing this kind of work. University of Delaware, New York, United States of America, Eiichi Nagishi for the University West Lafayette in United States of America, Akira Suzuki, Hokkaido University, Sapporo, Japan. These three scientists accorded with the Nobel Prize for their palladium catalyzed cross coupling in the organic synthesis, right? So there is a kind of a cyclic mechanism we can notice regarding this kind of palladium catalyzed reactions, right? Organic chemistry has developed into the art form where the scientists produce marvelous chemical creations, right? So organic chemistry is boundaryless. There are plenty of reactions, plenty of applications, and a lot of chemistry hidden in this, right? So many ways of applications we can find. Research explorators most prominently work in this field in the larger extent worldwide, right? Chemical creations in their test tubes. So test tube chemistry we can say, and that purely whatever they are doing in the test tube level. Initially, research always started with the minute level. If it gets success, then only it will go for the bulk preparation. So that we will consider whatever chemical creations are going on, they are created in test tube itself first, right? Mankind benefits from this in the form of medicines, ever more precise electronics, and advanced technological materials. Whatever chemical inventions, organic invention we are proceeded for, and they find applications in the field of medicine, because the highest pharmacopoeia potential is accorded with these organic moieties. And precise electronics, in the electronic field also organic compounds are more prominent, and technological materials also present. You can go for the application oriented material chemistry, where organic compounds are the kind of composition we can made up. Nobel Prize in the Chemistry 2010 awarded one of the most sophisticated tools available to chemists today. This year's Nobel Prize Chemistry awarded Richard Heck, and if Ichi Nagishi and Akira Suzuki for the development of palladium catalyzed cross-coupling reactions. Individually, they work. Individually, the mechanisms are provided, but they are worked on the collective motor, that is a palladium catalyzed reaction. Palladium is a kind of transition metal which is having highest provision. All the transition materials are having catalytic property, but palladium catalyzed reactions are more efficient in terms of the product yield and the quality of the product as well. So it is more convenient. Even in the laboratory, most of the people now adopted this kind of palladium catalyzed technology for so many kind of smooth preparation of chemical components now. This chemical tool has vastly improved the possibilities for the chemist to create the sophisticated chemicals. For example, carbon-based molecule as a complex as those created by the nature itself. So many molecules in the nature are composed by the carbon itself, so that carbon having its own kind of entities and complicated molecules. So in the nature itself, it got what inbuilt synthesis it already made up of. Carbon-based chemistry in the basis of life and is responsible for numerous fascinating natural phenomena. Color in the flowers, snake poison, bacteria killing substances like penicillin. Organic chemistry has allowed man to build on nature's chemistry, making the use of carbon's ability to provide a stable skeleton for functional molecules. This has given mankind a new medicine, a revolutionary material such as plastics. So many kind of materials are composed by carbon, even living organisms. Everybody aware that all living organisms are composed by cells. Each cell is the combination of carbon related polymeric substances only. So that we can say human being is a polymer of carbon, so that we are the part of organic chemistry. Not only that, so many medicines, revolutionary materials such as plastics also composed by these carbon containing compounds. In order to create these compound chemicals, chemists need to be able to join carbon atoms together. The proper way of their linkage, that is the synchronization, we can say proper optimized chain skeleton preparation is more important. However, carbon is stable and carbon atoms do not easily react with one another. In first method used by chemists to bind carbon atoms together, were therefore based upon various technologies for rendering carbon more reactive, right? So carbon, though it is able to form so many kind of skeletal auxiliaries, so many molecules, bunch of chemistry depends upon these carbon based compounds, but carbon itself not that reactive in improper way. There is a channel in order to go for its reactivity. Such methods worked when creating simple molecules, but when synthesizing more complex molecules, chemists ended up with too many unwanted byproducts in their test tubes. Whenever there are the certain kind of synthetic routes or synthetic pathways or synthetic methodologies when they are adopting in order to go for a new material synthesis, whenever a compound is going to be synthesized along with the required whatever you are striving to synthesize, apart from that, so many other products which are called byproducts may also generated within the test tube, because test tube is the main tool. First of all, the reaction minute synthesis started with the milligram level, nanogram level itself. So that test tube is the main tool where the new compound will be originated. After the successful establishment of the compound and the pure scale, then only we will go for the extension into the industrial scale or laboratory scale as well, right? So that in order to write the byproduct, there is a kind of technology we require. Proper methodology is required. That was overcome by palladium catalyzed cross coupling, which solved the problems and provided chemists with the more precise and efficient tool work with. Right. So whenever palladium introduced into that such kind of synthesis for a new compound, new organic compound, so palladium is more efficient transition metal and optimized catalyst, and which used to provide the high quality root of the method for the synthesis of so many compounds, not only a single one. This palladium is not having the tendency to generate only target product of one. Rather, you can go for so many ways of synthesis, so many types of compound synthesis, which are mechanized by this palladium catalyst. In the Hague reaction, Nagishi reaction, and Suzuki reaction, carbon atoms meet on the palladium atom, whereupon their proximity to one another kickstart the chemical reaction. Whenever these three scientists are explorating their research on their own field, so they chosen the very efficient palladium as the selective catalyst in order to go for the efficient completion of their reactions, whatever they are choosing. Whereupon their proximity to one another kickstart the chemical reaction, whatever reaction they are choosing. In that, palladium based catalytic conditions are provided so that entire path is moving in a smooth manner on the laboratory platform. Palladium catalyst cross coupling is used in the research worldwide as well as in the commercial production of, for example, pharmaceuticals molecules in the electronic industry. Whenever they got introduced, Heck, Nagishi, and Suzuki together introduced the efficient catalyst into the laboratory of chemistry, so that now it is becoming a widespread efficient catalyst in order to go for the synthesis of a numerous number of organic compounds under the efficient pathway. So that is the way it is a new kind of invention, we can say, by these three scientists together who are accorded with the Nobel Prize in the field of chemistry for this palladium catalyzed cross coupling in the organic synthesis. Move on to question number 2. Question number 2 is collected from Cambridge Assessment International Education, shows table 5.1 shows the properties of 4 substances. One is said to be aluminum, diamond, potassium bromide, and sulfur. These 4 compounds are provided with you so that boiling point values and electrical conductivity in the solid form, electrical conductivity when they are molten, and the density of these compounds in gram per centimeter cube. All this entire data is provided in the tabular form, so that we have to go for wherever blanks are present, we need to fill up. Wherever shaded one is there, that is not applicable, right? So let me go with this aluminum first. Whatever data provided, we will collect it first. Rather, later we will go for the vacancies, empty spots. Initially, aluminum was taken, whose boiling point is extremely high. So aluminum, why aluminum is having high boiling point value, melting point and boiling point of all the metals are higher. That is common for all the metals. Some simple characteristics are important characteristics can be given to the metals. If it is metal, that characteristic is applicable. One of the properties, melting point and boiling point values are high. That is common, right? So that you can directly put aluminum and even potassium bromide. Why potassium bromide is having higher boiling point value? Because of its bonding nature, that is formed by ionic bond. Ionic bond is electrostatic in nature, so that in order to go for that, higher temperature is required to be provided. Sulfur. Why sulfur is having low boiling point? Sulfur is sulfur is octaatomic, S8 molecule. It will be crown type of structure is accorded for the sulfur, and so many allotropes are also available. Rhombic, monoclinic, so many allotropic forms are available in the nature for the sulfur. Though this is of S8, boiling point is least for this one. How can we justify this? Because sulfur is of non-metallic substance, though it is in polymeric structure, but all are covalently bonded, so that it is accorded with the low boiling point value. This is the way we can go for the justification with the boiling point, and the diamond will not show the boiling point value, being it is the kind of diamond is the hottest material known on the earth. We already aware about that one. In order to cut the diamond, another diamond only required. That's the reason why diamond melting point is not required to be mentioned. It is the hardest material. Okay, move on to electrical conductivity of the solids. So what if the compound is said to be metal, so that certain properties are in by default we have to accord for that kind of material. So being aluminum is a metal, so that you can give the sentence wherever it is mentioned with the conductivity, you can put the tick mark for that one, because all the metals are good conductors of electricity. That is because of their electropositive nature, and the valency electrons are loosely bonded at their valency shell. Outermost electron shell is loosely bonded with the electron, so that there is a provision to pass or mobilize the electrons in the convenient way, so that electrical conductivity for all the metals are higher. So aluminum able to pass the current. So this is under solid, though it is a solid or molten material. So if we are taking, for example, let me go with our conducting metal, whatever we are using in our daily life, that is copper, right? So every time we are not going to melt that copper, rather it will be a conductor under normal solid condition only, because of its valency electron. In the similar manner, you can go for aluminum, being it is a metal, so that even under solid condition it able to pass current, so that conducts is the correct answer. Electrical conductivity when molten. So molten means what you are doing, take the aluminum and rise the temperature up to its melting point value, so that it will be melting. So at that condition, liquefied material is said to be conducting material only, because whenever it is becoming a liquefied one, so that electrons are more excited, and there is a feasibility for higher rate of conduction in comparison to the solid material. Solid being it is a rigid one, only electrons are supposed to be moved, but not a material. Material remains at the same place, but electrons are allowed to move one place to another. But under molten condition, or entire thing is in flexible form, so that electrons are allowed to move in a convenient manner, so that conductivity is exponentially raised by melting process. And move on to the density. If you go for the density of aluminum, it is provided with 2.7 gram per centimeter cube. This is the way aluminum properties clearly mentioned for you. And diamond boiling point is need not to mention, because already we are aware that on the earth, the hardest material is said to be diamond in the nature, right? It is a natural allotrope of carbon. And if you go for the electrical conductivity under solid conditions, it is not mentioned. We need to fill up. Okay, we will go with this in detail later. Whatever data which is with us, that we will look upon, right? Under molten conditions. So here melting, if you are not mentioning it's a boiling point, then assuming molten condition of diamond is practically impossible, being it is hottest material. We can't go for melting of diamond anywhere, right? And its density is said to be 3.51 gram per centimeter cube. In the potassium bromide, it is a kind of ionic compound. Potassium is the metal, bromine is the non-metal, so that electron transfer you can observe. Potassium is becoming K positive and bromine is a Br negative. So here, electrostatic forces are strongly binding, so that boiling point values are extremely large for the ionic compounds. Even potassium bromide is of ionic compound with the K plus and Br minus, but it does not show the conductivity under solid condition. Whenever it is in this solid form, there is no provision, there is no medium to move the electrons from one place to another place, so that conduction under solid conditions are not possible. Whenever you are melting or else you are dissolving in water, two provisions you can get. Take the potassium chloride and add to the beaker of water, or else take the potassium bromide and you can rise the temperature until the melting point reaches. Then only there is a provision to get the conduction due to the passage of ions. Here, aluminum shows the conductivity because of electron movement. Potassium bromide shows the conductivity due to the movement of ions. This is called ionic conductance, and this aluminum is called electronic conduction. There is a kind of a stratification you can notice, and its a density. Potassium bromide density is given as 2.71 gram per centimeter cube. Sulfur is being it is a non-metallic, so that boiling point is accorded with the low boiling point will be there, and electrical conductivity under solid condition does not conduct, right? Sulfur non-metals are not able to pass the current, so that conductivity will not be there. And electrical conductivity upon melting, molten condition we have to go for, and its density is provided with 2.07. Complete the table 5.1, electrical conductivity of solid diamond and molten sulfur. These 2 points to be filled over, right? State one piece of evidence for table 5.1 that shows the sulfur is the simple molecular substance, right? Simple molecular substance, how can we say it is the simple molecular substance? Because sulfur is able to form AC8 type of molecular structure, and it is available in the form of that molecular form rather than the elemental form. Always molecule, AC8 is the kind of molecule. We can say that molecular substance is existing for that sulfur. Okay, this is the way we can answer. And let's see how can we fill up these vacancies over here. Electrical conductivity of 99.9% pure aluminum at 200 degrees centigrade is said to be 63.8. International annealed copper standards is provided with, so that this extent of conduction we can notice because of its low specific gravity, mass, electrical conductivity. Pure aluminum is more than twice of annealed copper and greater that of any other metal. Whenever it is rise temperature got increased this extent, this is not exactly at room temperature. So obviously at the room temperature, silver is of higher conductivity and the next followed element is copper. There is no doubt. But this is the condition provided for the aluminum at 200 degrees centigrade. At this 200 degrees centigrade, pure aluminum more than the twice of annealed copper, right? So that at the thermal conditions, the properties entirely varied. We can't justify whatever properties are there at room temperature may not remain same at elevated temperature. So that upon rising temperature to 200 degrees centigrade, pure aluminum is having higher rate of conductivity and twice the conductivity over copper. This is the way comparison is provided with, right? So, and let's move on to diamond. So there is a question, we have the vacancy over here. We need to go for the conductivity of diamond. A diamond tends to dissolve in the iron-based alloys and at higher temperature, essentially carburizing alloys, making the abrasive less effective. Everybody aware that diamond is of highest abrasive material. Abrasion tendency is extremely large for this diamond, so that it is the hardest material in the entire natural compounds. This material is generally used most machine polishing applications. Wherever polishing is required, so being it is the hardest material, we can go for its machine polishing applications, right? So this is regarding the quality of diamond. And move on to its conductivity. Conductivity of this diamond is said to be less, we can say, being it is the kind of sp3 hybridized carbon. All four valency electrons and the carbon atom got participated in the covalent bond formation, so that conduction is not applicable for this one, right? And move on to another topic called sulfur. Even under molten condition, there is no provision to go for the conductivity. No conductivity we can notice for the sulfur, being it is a non-metal, right? For the diamond, poor conductor you can mention. For sulfur, no conductivity we can mention. So this is the way all two vacancies got filled up. And evidence from that why sulfur existing molecular substance means sulfur, being it is the polyatomic. Polyatomic means AC8 will be there. AC6 sulfur also available, but in the lesser extent. Availability of S6 is somewhat a trace in amount, but abundantly available sulfur forms, whatever rhombic, monoclinic, everything is available in the form of AC8 only, right? So that we can say it is the molecular substance and covalently bonded. So if you go with iodine, iodine is also the best example for the molecular solid. Sulfur is also the kind of molecular solid, we can say. This is the way all the questions got answered for question number 2. Let's move upon Question number 3, it is collected from 2016 JEE Advanced Question Paper 1. And the National Testing Agency conducted the exam extraction of copper from copper pyrites. Copper pyrites is designated as copper iron sulfide involves. Whenever copper extraction from copper pyrites involves crushing followed by concentration of the ore by froth flotation is required. Removal of the iron as a slag is required. Self-reduction step to produce blister copper followed the evaluation of sulfur dioxide is required. Refining of blister copper by carbon reduction. This may not be possible. Let's see how can we say these are possible. Here, in order to go for the purification of copper pyrites is nothing but copper iron sulfide is called copper pyrites. There are different methods are available. One is called froth flotation, second is called thickening, third is called smelting, fourth is called electrolysis. These many methods are there. Among all, froth flotation, they are asking for froth flotation, because within the option they are provided with the froth flotation process. In general, froth flotation is applied for specifically for sulfide ores. Wherever sulfide ores are present, there we have to adopt the method called froth flotation, right? So in this copper process, copper development, air is pumped into each cell solution being agitated to bring the froth. So the requirement, froth flotation means what? Froth means what? There is a formation of lather upon, right? Whenever we are bubbling the air, so that oily type of substances, whatever present, they are able to form the mesalli, and that used to form a foam upon the surface, which is called a froth flotation. That kind of material will be subtracted, okay? So pumping of air or bubbling of air is the most important step over here, so that whatever substances they're entirely becoming a froth upon the surface. In the case of copper minerals, the particles adhere to the froth, which is separated. So whatever copper particles are present, they will be attached to the froth, whatever floating on the surface of the liquid layer. The entire liquid froth layer to be separated, and that further supposed to be go for refining process, so that you can collect that copper. This is the way froth is the source in order to collect the copper over here. Whereas a great bulk of the useless material sinks to the bottom of the tank. Whatever heavy material is there, that will be deposited at the bottom, and that can be removed. Okay, so the required part of the froth flotation will be top layer only. Whatever floating on the surface of liquid, that is required to be taken, collected from the surface, and further refining process to be applied. This is the process called froth flotation. Okay, this is the entire apparatus and the device which used to go for the process called froth flotation. So in order to go froth flotation, entire mineral dissolved in the suitable solvent is taken in this entire the big container. And here we have the provision to agitate this one. So rotation provision is there, flotation process is occurred, and air supply will be there. Air is pumped from this outlet, from this inlet, air supplied. A bubbling of air is possible over here, and the feed is provided in this liquid form. Bubbles are generated because we are agitating, right? Just like a chunking of what we can say that ghee generation. So in the similar manner here also kind of bubbles are generated, and slurry formation is possible, and agitator is required. We have the provision to agitate with the fast revolutions per minute, so that agitator is required. So by this kind of agitation, there is a formation of layer on the surface, just like how we are getting ghee layer on the surface of that butter. In the same manner here also, froth will be generated on the surface. That froth is required to be collected, and whatever heavy particles are there, they are deposited at the bottom. That should be discarded. That is the kind of a byproduct we can say. Whatever impurities that can be, only the requirement is here froth can be collected. Further we will go for refining methods, and this is the entire description of froth flotation process. Until quite recently, copper had to be hand picked. So earlier hand picking method is prominent for the purification of copper. But today, such ores rich in copper are scarce in the great majority of mines contains the metal in finely disseminated particles which aggregated anything 2% down the 1%. This is the way. Nowadays, we are going for the advanced technologies. Froth flotation can be applied for this iron pyrites ore in general. First of all, we have to go for pumping of air is possible and solution being agitated, bring froth bubbles on the surface. And whatever copper is there that remains in this froth only, which can be separated and a great bulk can be suspended at the bottom. Whatever we studied that repeated over here. And here is the entire mechanism. You can notice copper is extracted. Our copper pyrites by froth flotation process. Froth flotation method is used to separate particles based on the differences in the ability of air bubbles to selectively attach the mineral surfaces in the mineral water slurry. Whatever mineral and water combination is there, whenever you are agitating, so particles to be attached on the surface based on that attachment tendency, binding tendency, then only the extraction process totally depends. A finely crushed ore can be taken. This is the step number 1. Finely crushed ore can be taken in the froth flotation that should be indicated with the tick marker. After getting that, wet particles to which air bubbles are attached float as the froth with is skimmed, and whereas particles to which air bubbles are not attached gets heavy and sinks into the bottom. Copper is extracted. The principal ore copper pyrite is copper iron sulfide. The ore is concentrated by froth flotation. Concentrated ore is then roasted with the furnace in the to remove the sulfur and arsenic gases. So sulfur and arsenic gases are removed by oxidation process. This is the way. So sulfur can be removed. Let's see whether it is there. Remove iron will be removed as the slow. At the bottom, precipitation will be there. No, in that whatever precipitate which can be discarded is said to be a slag, unwanted material in that. So this is the way slag can be removed. Iron or else any other materials whichever present heavily, those can be. So because why we are specifically mentioning iron means within the ore itself we have the composition of iron, right? So that iron can be removed as a slag. Self-reduction step produce a blister copper by the evaluation of sulfur dioxide. So just now we saw sulfur removed in the form of sulfur dioxide over here. Whenever sulfur dioxide is removed from that system, whatever copper remains in that, which is said to be blister copper, right? So that is called blister copper. What is the next point they mentioned? Refining of blister copper by carbon reduction. Whatever this blister copper is there by the evaluation of sulfur dioxide, that copper can be further refined with the carbon reduction. So they are saying carbon reduction. Let's see whether it is there or not. Here, copper iron pyrites oxygen copper sulfide plus iron sulfide sulfur dioxide. These sulfides then oxidized by the smelting process. Copper is extracted successfully, so that carbon is not required to be used over. So that so this process can be discarded. Blister copper carbon reduction may not be applicable. Rather, we have to go for the method required is oxidation process. Oxidation only required, right? So this is the way. Option A is correct, B is correct, C is correct, D is wrong one, right? Move on to question number 4. Question number 4, the nitrogen containing compound produced in the reaction of nitric acid with the P4O10. This is the polymeric oxide of phosphorus P4O10, tetramer we can say. If 4 atoms are getting combined, so that is said to be tetramer. Okay, tetramer of phosphorus oxide combines with the nitric acid. What is the compound generated? That is nitrogen containing compound will be formed. Okay, can also be prepared by reaction of P4 with HNO3. Whatever compound formed by this method, A same will be formed by P4HNO3. This is not correct. Another product will be formed. We will see the difference. It is diamagnetic. They are saying whatever compound is generated is called a diamagnetic. That is correct. Contains one nitrogen bond. So if we see the compound first, then only we can identify nitrogen bond is there or not. Reacts with sodium metal producing brown gas. Whenever the product generated here, that is nitrogen compound, that should be treated with sodium metal. Whenever sodium metal is added to that, so here one gas is produced in the brown color. So that is correct. So for question number 4, option B and option D are said to be correct. We have to check whether it is possible answer or not. Okay. The reaction is nitric acid can be treated with tetramer of phosphorus oxide P4O10. There is a possible reaction called a dehydration. Whatever water molecules are there entirely removed. Whenever water removed, anhydrous N2O5 will be generated. N2O5 is the precursor for the synthesis of HNO3. Everybody know that. In order to synthesize HNO3, we have to take the N2O5, nitrogen pentoxide, as a starting material. Okay. So whenever it is hydrated, back converted into HNO3. Whenever dehydration of HNO3 is carried, so that N2O5, nitrogen oxide, will be formed. That exists in the form of angular structure. You can notice nitrogen having double bond O, one dative bond oxygen, one ethereal oxygen will be there, and nitrogen double bond O, and another dative bond will be there. This is the way N2O5 can be represented. Okay. Whenever this N2O5 is there, the N2O5 is said to be diamagnetic in nature. How can we say diamagnetic? All the electrons on the nitrogen are paired up, so that it is diamagnetic, and diamagnetic is the correct answer only. So if you go for NO, N2O, nitrous oxide and nitric oxide, among the all oxides of nitrogen, only two are paramagnetic. What are those? One is nitrous oxide, second is nitric oxide. But this N2O5 is diamagnetic only because no free electrons are available. Okay. And contains one nitrogen bond. If you see the structures, is there any nitrogen direct bonding? You can't find it, right? So that you can't put the tick mark for this one. Then reacts with sodium metal producing brown gas. Whenever sodium added to N2O5 molecule, nitrogen oxide molecule, there is a formation of sodium nitrate and nitrogen dioxide. Here, sodium nitrate and nitrogen dioxide will be generated. The nitrogen dioxide molecule is called brown color gas. This is the way brown gas is generated. That is the correct answer. For question number 4, option B and option D are the correct answers. Let's go with the question number 5. Here another provision we have. They are saying another this part. P4 can be reacted with HNO3. The same product we have to achieve. But whenever phosphorus, in general, in nature, phosphorus available in different allotropic forms. Though different allotropes are possible, but atomicity of phosphorus is P4 only, right? So P4 can be bonded to HNO3 so that under moisture conditions, H3PO4 will be formed and nitric oxide will be generated. Can you find the similarity with this? N2O5 and NO is both same or different? Obviously, both are different, so that you can put a wrong mark for the option A. P4HNO3 is not giving the same product as HNO3 with P4O10, right? So here only B and D are the exact answers for the question number 4. Then we entered into the question number 5, which is collected from Telangana MSET examination conducted in the year 2022. The Kp value at equilibrium of sulfur trioxide formation reaction from sulfur dioxide and oxygen is 5 atmosphere inverse. What is the equilibrium partial pressure of oxygen if the equilibrium pressure of sulfur dioxide, sulfur trioxide are equal? Okay, it is the kind of numerical based on the solubility product. Okay, so here this equation, this problem is given from the chemical equilibrium chapter, and expected answer is option number 1, 0.2 atmospheres is the correct answer. In order to solve this one, we have to go for the explanatory part for this one. Expression for the Kp value. Kp is equal to equilibrium constant is equal to product concentration by reactant concentration. How can we write this? Because whenever SO2 combines with O2, then only product SO3 will be formed. SO2 and O2 are called reactants. SO3 is called what? Product. So that, let me put on products by reactant concentration. Product is SO3. Okay. So being all these are gases, right? You can see sulfur dioxide is a gas, oxygen is the gas, sulfur trioxide obviously is the gas only, right? Being all these are the gases, so that instead of concentration, the term related is called the term relevant is called the pressure. So that, let me put PSO3 over here, P for pressure. Okay, gases measured in pressure, liquids solutions measured in their concentration. So that, let me put the pressure SO3, and being 2 moles of SO3 generated as the product, so that take the square for this one. And starting materials, what are the starting materials? Sulfur dioxide and oxygen. Okay, so pressure of sulfur dioxide taken twice again, because in order to synthesize 2 moles of SO3, 2 moles of SO2 required. Then pressure of oxygen, product concentration by reactant concentration was taken. Then partial pressure of oxygen, which already provided with you, that is 5. So that 5 is equal to PSO3 whole square by PSO2 whole square into PO2. Okay. Within the problem, what they mentioned, equilibrium pressure of SO2 and SO3 are equal. So pressure of SO2 is equal to exactly the pressure of SO3. So if these two are exactly equal, you can cancel out these two parameters, because both are equal, right? If here the value is 10, in the denominator also 10. 10 divided by 10, you can cancel out, so that both are compatible. The equation is simplified as phi is equal to 1 by PO2. Then PO2 is required. Pressure of oxygen is required to be calculated. Let's put over here. PO2 is equal to 1 by 5. 1 by 5, the value will be 0.2. 0.2 atmosphere indicated in the option 1. For question 5, option 1 is the correct answer. Let's move on to the last question of the session. This is the match the following. Again, solubility product. This is the question came from a chemical equilibrium part. Metal sulfide was taken and solubility product is provided. Okay. Whenever this is the condition, metal sulfide and solubility product table is there. This is the kind of data. It is data-based question, so that we have to go for the specific answer rather than going for the calculation. Specific answer required to be identified. Metal sulfides. So these are all naturally occurring minerals, we can say, ores, we can say. Okay, what are those? Lead sulfide, mercury sulfide, manganese sulfide, and zinc sulfide. Their solubility products are provided. Why this data is important? Any statistical data, if we are collecting, there should be a kind of application. This solubility product is also more important, because whenever you are extracting these minerals from the earth crust, we have to identify whether it is water soluble, how extent solubility. So that solubility product plays a role over here. So based on the solubility only, we will go for the selection of the solvent, right? So this is important data, we can say. So let's see the table for this one. This is the expected answer. Before going to answer this one, we have to go for the table. Metal sulfide, if silver sulfide is there, that mineral is called, scientifically called as a cinnabar, whose solubility product is provided with 4 into 10 to the power minus 53. Cinnabar, we have this mineral in our problem, right? Copper sulfide is called present cobalite, we can say. It is not there with us. Lead sulfide is there, that is called galena. Galena is there in the problem, so that 8 into 10 to the power negative 28 is the solubility product. Cadmium sulfide is not there with us. Greenockite is the name of that mineral. So whose value is exactly resembling with lead sulfide only. Zinc sulfide is called as sphalerite. This is there in the problem. Zinc sulfide is called as sphalerite, whose solubility product value is 1 into 10 to the power minus 21. Iron sulfide pyrite, we can say it is not given, I think. 6.6 into 10 to the power negative 19. Nickel sulfide called millerite, 3 into 10 to the power negative 19. Here is another one called manganese sulfide called hurite, and whose solubility product is 2.5 into 10 to the power negative 13. Let's go for, after getting the entire required statistical data, we have to go for mapping. Lead sulfide value is expected to be 8 into 10 to the power negative 28. Silver sulfide is given with 4 into 10 to the power minus 58. Manganese sulfide 2.5 into 10 to the power minus 13. Zinc sulfide 1.6 into 10 to the power minus 24. This is the way. Let me repeat again. Lead sulfide solubility product is 8 into 10 to the power minus 28. Silver sulfide is 4 into 10 to the power minus 53. Manganese sulfide is 2.5 into 10 to the power minus 13. Zinc sulfide is 1.6 into 10 to the power minus 24. Why this data is important? If you know the solubility product only, then only we will choose the suitable solvent required for the extraction. All these are the minerals only. Lead sulfide if present, what we can say? Lead sulfide is called galena. Silver sulfide is called mercury sulfide is called cinnabar. Manganese sulfide is called hurite. Zinc sulfide is called sphalerite. Zinc sulfide is called sphalerite. Okay. All these minerals having their own solubility product and the mapping is required. That is given in the option number 2. A can be suitable with the 2. B can be with 1. C can be with 4. D can be with 3. This is the way entire session got completed. And we gone through the various dimensions of chemistry with the organic mechanism to the complicated numericals and tabular statistical data is also got analyzed, melting point, boiling point values, different dimensions of chemistry covered over, and the authentic informative session was conducted. Those who are following the series of sessions, whatever we are conducting, definitely they will crack the exam, whatever they are aspiring for, being it is the kind of session collected from the repeated question in the previous examinations. You can go for for sure success in your examinations which you are aspiring for. So I am sincerely requesting for like the channel, comment. In order to comment, we have a question over here. Commenting question for the session will be, whenever you are going with whatever ores you know, just to mention any 5 important ores. So in that you can go with iron containing and also nickel containing, copper containing ores. Iron, nickel, copper containing ores, any 5 you can mention for the session in the comment box, and share with aspirants who are most curious about the examination, and subscribe the channel so that we will go for new content in the near future. Thank you. Thank you one and all.